5-28. Gail and Leslie are riding in a friendly 60-mile bike ride that started at noon. The graph at right represents their progress so far. Okay, let's take a look at this graph. The x-axis is the time of day, and apparently it started at noon, and then we go up by increments of 1 hour after that. And then the y-axis is distance in miles. So, of course, they started at 0 miles, and then it went up by 10 miles each time after that. All right, and then if we look at what's actually graphed, Leslie is this line, and she apparently starts and just goes at a steady rate the whole time. Whereas Gail starts out actually going faster than Leslie because her line is steeper. But then when she gets to here, she doesn't have any more miles. For a long time, she doesn't go anyplace. The time goes by, but the mileage doesn't change. She's staying in the same place. And then she takes off again. Okay, so let's go ahead and see if we can answer some of these questions. What does the intersection of the two lines represent? Okay, so that's the intersection of Leslie and Gail. So it looks like Leslie is first of all, Gail was ahead of Leslie. She was going faster than Leslie. But then Gail stopped, and so while she was stopped, Leslie actually passed her. So this intersection represents the place where Leslie passed Gail in mileage. So it represents the time when Leslie passed Gail. So it's not just the time, it's the time and mile when Leslie passed Gail. Okay, let's go on to B. All right, at approximately what time did Leslie pass Gail? Okay, so if we look at this, it looks like it was about 2 o'clock. Okay, so let's write that down, 2 p.m. All right, and the C, about how far had Leslie traveled when she passed Gail? Okay, so we know the time by looking at the x-axis, but let's see how this matches up with the miles. It looks like it's about 18 miles. So 18 miles is the answer to that. And then what do you think happened to Gail between 1:30 and 3? So that is the time. So 1:30 is about here and 3 is about here. So that's the time when Gail was stopped. So probably her bike broke or maybe she got a flat tire. Okay, so something happened to Gail's bike. And then we'll put like maybe flat tire. Although she probably would have been able to fix that. It might have been something more serious. Okay, let's see. E. If Leslie continues at a steady pace, when will she complete the race? And so if Leslie just keeps going, when is she going to finish this race? Okay, so we already have some information. We know that Leslie actually was at 18 miles at 2 o'clock. So 2 hours after the race started, she was at 18 miles. So we can make a ratio of that, 18 miles to 2 hours. And then we could find the unit rate, which is 1 hour. So we just divide 18 by 2. So she was going 9 miles per hour. So that's her unit rate. And let's see, we want to know when she will complete the race. And the race, if you look up at the question again, is a 60-mile bike race. So if we divide 60 by 9, we will find out how many hours, because she can go 9 miles in 1 hour. So 60 divided by 9, let's see, we know it can go in at least 6 times, because 9 times 6 is 54. And then there would be 6 ninths left. So that's like 6 2/3. And 2/3 of an hour, let's see, if we divide an hour into thirds, that's 20 minutes for each third. So 2/3 would be 40 minutes. So 6 hours, oops, that's a funny R, and 40 minutes. Okay, so she'll complete the race in 6 hours and 40 minutes.